Alright, so sound waves and Doppler effect. Let's do some page 1. Okay, page 1 is not very hard, especially when it gets broken down a little bit. Hopefully that's not too much light. I'm trying to give it a little bit of light, but not much. There we go. Alright, so let's do some true and false. If you guys feel confident, pause, skip this video and do it yourself, and then use the video to check it. Otherwise, let's rock and roll. Alright, sound waves are longitudinal waves. So, we talked about this, right? Longitudinal waves are waves that go longitude. So longitude, long, kind of like flat, right? So in other words, they're compression waves. Like if you have a slinky and you shake it like this, that's a compression wave. Transverse waves are like this. So sound waves are not transverse waves. They are longitudinal waves, right? So that is true. All right, as a teacher talks, students hear voice particles. Hear the voice because particles of air move from the mouth of the teacher to the ear of the student. First of all, how gross would that be? Even if you're in the back of the room, I'm talking to you, and like my air inside my mouth, my breath is going in your ear. Wouldn't that like suck? That would be kind of gross, right? So no, that's not true. But the vibrations we make, because sound is a vibration vibrating through objects, goes through the air particles and travels through that air particle. Because if you watch the intro video, remember that sound needs a medium, and in this case it's air to go through. So when I'm talking now, my voice is vibrating through these air particles towards the microphone. Okay? So, as the teacher talks, blah, 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 no, that's false. That would be gross if it was true. All right, number 3, sound waves are mechanical. Mechanical means there's some kind of like movement or motion involved, and that's true because yeah, it's traveling through something and it's vibrating. So yeah, that is true. All sound waves are produced by a vibrating object. Well, yeah, that is also true. So yeah, you talk, vibrates through the air, blah, 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 good. Sound wave does not consist of crests and troughs. Well, this is a crest. I believe this is a trough. And remember, this is sound. This is like a normal wave, right? So this is like electromagnetic radiation stuff, and this is like sound. So in that case, that would be true. It does not consist of it. Awesome. Let us move to number 6. Like I said, if this stuff is easy, the videos are gonna be kind of long, and it usually, especially with pages like this, if you know it, it's faster for you to just do it than sit down and watch this video. So if you're watching this and you're like, man, it's really easy, I could just do it, you don't have to watch this video. You just do it, right? And if you already know it and you just want the answers from the video, you can do that. But it sure does suck sitting through a long video when you don't have to, right? Because you already know it. Okay, so Mac is talking to Kate. The dot at the A represents a particle of air. Describe the motion of this particle must undergo in order for Kate to hear Mac. Then show the motion by placing arrows in the diagram. So, the motion this particle must do, well, it's vibrating, so it's just sort of left and right. That's a left arrow, right? And we're just going to describe it. So we'd say it should vibrate back and forth. Cool. Something like that. You don't have to put that exactly, but something like that. You shouldn't be up and down, right? Because it is a transverse wave. Did I say that right? Yeah. No, longitudinal wave. Sorry. Okay, number 7. Tosh. Daniel Tosh is holding one end of a slinky. Suppose the opposite end is attached to a wall. Daniel Tosh wishes to produce a longitudinal wave in the slinky. Describe how Tosh must move his hand in order to produce a longitudinal wave in the slinky. So, longitudinal wave, in other words, this longitudinal wave, right? So, longitudinal. It's a long word, right? So, well, that's easy, right? Same kind of deal. Back and forth. You push it in, you pull it back. It compresses, and then it sends that compression along the slinky. Cool. So however you want to word that, make sure you do word it here. Something like he must push it and pull it, something like that. All right, number 8. Okay, a sound wave is moving through air. The diagram represents a snapshot of the air particles at a given instant in time. Several regions are labeled with a letter. Use the letter to identify the compressions and rarefactions. Okay, so in other words, you got to group the letters here and here. So in other words, this question is asking, did you do the vocabulary? Do you know what rarefactions are? Because obviously you know what compressions are, right? So compressions are the points where the air is compressed. Well, when it's compressed, that means it's more dense. So the air where it's more dense is A, C, E, G, I, and I almost wrote J, but it's K. J, K. Okay, so rarefaction, hopefully you did your vocab, but rarefaction is like a point of, decompression or less density in an object. Usually it's having to do with air. So that would leave like B. Notice it's a little bit B, D, F, D, F. So this, H and J are pretty less dense. H, J. So notice that it's getting compressed, then it's getting less dense. Then compressed, then less dense. These are rarefactions. Okay, so now you know. Awesome. All right, let's look at number 9. A science fiction film depicts inhabitants of one spaceship in outer space hear the sound of a nearby spaceship as it zooms past at high speeds. Critique the physics of this film. So this is where this stuff kind of comes in handy. And this is why I like physics, because you always hear the question, when am I ever going to use this? Well, you can appreciate things more when you understand them. Like when I watch you watch Star Wars movies or any kind of movie dealing with outer space or sometimes on Earth, and you understand why something happened the way it did, why something fell the way it did, why a sound sounded the way it did, because you understand it. So with this one, they're saying, it's in space, and they hear the sound of a nearby spaceship when it passes them at high speeds. Critique the physics. So now you're a film critic, right? Well, remember that sound needs a medium. Usually it's air, but it could be a liquid and it could be a solid. But in space, there's not really any particles because it's a vacuum. It's almost a complete vacuum. I think there's a few little bit of particles, but for our purposes, it's a complete vacuum. So would they hear anything? No, they wouldn't. They wouldn't hear anything. There would be no sound. So in that case, it would be impossible because there's no air, which means there's no sound, however you want to write that. So there you go. We did page 1. It only took us 8 minutes. If you got any questions, let me know.